So this is problem 16.9 and the exercises at the end of chapter 16. So the question is, or the situation is this. A class survey in a large class for first-year college students asks about how many hours do you study during a typical week. The mean response of the 463 students was 15.3 hours. So right then and there, we have some data. So I'm just going to sort of keep track of this data on the side here. So what we're given is that we have a mean response of 463 students. So n, our sample size, is equal to 463. Our mean response, which is x bar, x bar, is 15.3 hours. And this is 463 as students. So what else do they tell us? Suppose that we know that the study time follows a normal distribution. So that should let us know that we can actually plot this, excuse my curved lines here, as a normal distribution. And it says a standard deviation of 8.5 hours. So we can put our standard deviation is 8.5 hours. And that is for the population of all first-year students at this university. Okay, so I'm not even going to read the question yet. I'm just going to sort of get my data in order. What have they given me so far? So they've given me sample size, they've given me x bar, which now I can actually put on this graph. Just doing a different color. So this is our x bar right here, and this is 15.3 hours. That's a 3. And they've also given me the standard deviation, population standard deviation, which is 8.5 hours. Now I'm not going to draw the population standard deviation here. I don't want to muddy up the graph here. So now let's just move on to the questions. So it says use the survey result to give a 99% confidence interval for the mean study time of all first-year students. So in order to answer part A of this question, we need to know what the confidence intervals are for what the z-score is for any of these confidence intervals. And then we want to actually apply that z-score to our calculation. Now, if we want to figure out what the interval is, the confidence interval is, we use the formula x bar is plus or minus some z-score, depending on what confidence what confidence level you're looking at or you're considering. And I've actually added over here sort of a listing of what some of the typical confidence levels are, but I believe you can go down as far down as 80, I've seen. So anyway, so the z-score for the confidence level times the population standard deviation divided by the square root of the sample size. Now this part of our calculation should look familiar. And the only thing we're doing here is we're adding this multiplier, as I like to think of it, is a multiplier that basically gives us that interval that we're looking for, given whatever we choose over here as our C value for the confidence interval. So this is my formula that I'm going to be using, this guy right here. So I have all the data I need in order to solve this problem. So I know that I'm looking at a 99% confidence interval. So that means I'm looking for this value right here, the 2.576. So that's my Z. And I can write this as x bar equals, or I'm sorry, plus or minus. Erase that. Plus or minus. And then I want my z-score here for my confidence interval, which is going to be 2.576 times, and then I want the data that was given at the very beginning. So that's the sigma, which is the standard deviation, population standard deviation, which is 8.5, divided by the square root of the sample size, which is 463. And if you work through some of the math on this, you should get 15.3 plus or minus 1.018, which is equal to 14.282 all the way to, and this is a range, remember, 16.318 hours. And essentially, if we look at this in terms of our normal curve, we're essentially saying that between these 2 points, so this is our 14.282, and this is our 16.318. So essentially, anything that is within this range, that falls within this range right here, we can say with 99% confidence that the mean will fall within this range of values. Now, if we look at the second part of this question, it asks, what condition not yet mentioned must be met for your confidence interval to be valid? So if we think about this, this is actually a slightly tricky question because you're probably thinking you have to calculate something, but actually all they're just asking here is the condition is that the 463 students, the sample that we've chosen, has to be a random sample, and it has to be a random sample of all of the first-year students at the university. Otherwise, it doesn't really satisfy those conditions of inference that we're talking about. So that kind of wraps up question 16.19, and hopefully this will help you with one of the problems that is a little further down, which is part of your assignment, which I believe was 16.23 maybe, or 16.20, I forget. So anyway, enjoy, and bye.